In this video, let's talk more about registers in ARM. A register is a small but fast storage location within a computer's CPU. Registers are used to quickly store and retrieve data that CPU needs to execute. They are essential components of a CPU, enabling it to perform calculations, manipulate data, and manage execution flow efficiently. ARM architecture features a set of general purpose registers. There are 30 general purpose registers in 32-bit architecture that are used for arithmetic, logical operation, and data movement. The number and naming of these registers slightly vary between 32-bit and 64-bit ARM architectures. The first 16 registers are accessible in user level mode. These 16 registers can be split into two groups: general purpose registers and special purpose registers. Now let's see 32-bit ARM registers and how they relate to Intel 32-bit architecture. The first register in ARM architecture is R0, that is a general purpose register, and you can relate it to EAX in Intel. While R1 to R5 are also general purpose registers, but you can relate them to EBX, ECX, EDX, ESI, and EDI in Intel. R6 and R10 are also general purpose registers, while R11 is a frame pointer and R12 is used for intra-procedural calls. R13 is a stack pointer. Stack pointer points to the top of the current stack and is used for the function calls, local variable storage, and context switching. You can also relate it to ESP in Intel. R14 is a link register. It stores the return address for the subroutine calls and facilitates nested function calls and returns. R15 is a program counter or instruction pointer. You can relate it to EIP in Intel. The program counter holds the address of the next instruction that is to be executed. It automatically updates when each instruction is fetched. CPSR or current program state register. You can also relate it to E flags in Intel that indicate the current state of the processor. Example 0, negative, carry and overflow. It controls processor modes and interrupt setting. Now let's further discuss CPSR. The following table shows the flags that are available in the CPSR or current program status register. The first flag is a negative flag. It is set when the result contains the value that is negative. Zero flag. It is enabled when the result or the value is 0. Carry flag. It is set when the value requires 33-bit to be fully represented. Overflow flag. It is set when the value cannot be represented in 32 bits 2's complement. The next flag is a jizzle flag. The third execution state that allows some R processors to execute Java bytecode in hardware. The next flag is Indianness flag. It is set 1 when the ARM processor works at Big Endian mode and set 0 when it works at Little Endian mode. The ARM can operate either in Little Endian or Big Endian. The next flag is thumb bit flag. This bit is set if you are in thumb state and is disabled when you are in ARM state. In the next video, we will talk about Indianness.